think. They think. They speak Spanish. They don't know I'm white.
I don't know if that's an expectation you want to set up.
That's just how it is.
All right.
Okay. 45% of 200. Jeff said I could use the calculator.
Once you get the equation set up.
Yeah.
Okay.
So it's
Easy.
yeah. So it's of. So wouldn't it be 0.45 divided by 200? It's multiplied because it's of. So it's x equals, meaning like do x equals, and it's just like that answer. So it's 0.45 times 2.
So I'm going to slowly start to catch up to you guys.
Which is probably.
I haven't done shit yet. It always makes me cry a little tear when somebody does this for this problem. We talked about this before. No, this says 3 divided by 5. So you could do 5 goes into 3 and all that kind of shit, or you could just make the bottom become 100. So multiply by 20. So you get 60 over 100. So now I know that's 60%.
Yeah.
And I know that's 0.6 when you move it back twice.
15.
Stop for a second. Is that cool? So you have a few different ways. If you have a fraction, fraction means divide. So to make it a decimal, you actually do that operation. Or you just make the bottom become some multiple of 100. Multiple of 10. What was the next one? 42.
Do I look 24?
Guys.
24, 30, 35. That's
So the decimal currently is right there. Just remember this, the percent number will always be bigger than the decimal number. Because the decimal number is what results from dividing. So of course it gets smaller. So once, twice, 0.42. And if you just read this, 42 per 100, and of course this is in the hundredths place, so everything says, make it like this. Yeah, like it?
So unless it says reduce.
Yes, I like it. Huh? I'm going to do all of them.
He's doing all of them.
Here we go. So this is basically the same problem. You see that? So if I move it over twice, bam, bam. And that's in the hundredths place. Bam. Coolness. I like it. You guys will pick up on a few of those. Have I done maybe yet? Okay, maybe. I don't mean to do that for any of these, I just do it. 0.03%. They already look so tiny, but the poor little dude's going to get even tinier. 1, 2. So it'll be point. Why do I give myself no room? 0.0003. So that's in the what place? Tenths, hundredths, thousandths, 10,000ths. So it's 3
Over 10,000.
Now watch this. This is kind of cool. Why is this wrong? Watch. What's percent mean again? Out of 100. So that is not acceptable for a fraction answer because a fraction is supposed to be a ratio of whole numbers. So don't I just multiply top by 100, multiply bottom by 100? It's the same answer, right?
Okay.
So you could actually do any percent, even if it's a decimal, put it over 100. As long as you move it over so that they become whole numbers, you're golden. There's always more than one way to do it. Yes?
The 42 over 100, I should have read it as 21 over.
Yeah, I said don't worry about reducing these specifically. Yeah, this kind of problem would be on a section I wouldn't let you use a calculator for, but if it was, and I put this problem, if you know your fraction buttons, it always gives you a reduced version. That's why I'm like, I'd rather not see the reduced. Because then I feel a little bit better that it didn't just come out of the calculator. Anyway, all right. 1.12. So 1 is what percent? 100%. If I got 1 pi, I got 100% pi. So this is going to be a little bit more than 100%, so it kind of makes sense that it's 112%. And then you can write the fraction either as 112 over 100, or 1 and 12 hundredths. Because these are the same thing, aren't they? One's just mixed number and one's improper. Oh, it's improper. I love that word. Could be just me. And then 5/8. Can I make the bottom become 100? Easy. No. Shit. So then I have to do what? Yes. Well, anyway. So if you long divide that bad boy, 6, 48, 20, 2, 16, 45. 165. If I don't say round, that means I gave you a problem where it does stop naturally. So this will be 0.625, and therefore this will be. Now, real quick, what's a 1/4? 25%. 0.25, right? So what's 1/8? Half of that, 12.5%. What's 4/8 would be half, 0.5. Plus 1/8 is 0.125 is 0.62 freaking 5. Or forget everything I just said. Yeah. Okay. All right. Yes.
No, I was just doing the okay.
Oh, good. I was down in Peru. I had a girlfriend who comes from Peru. We went down there, I met her grandfather, and at one point he said something and I did this to him. And come to find out in Peru, this basically means you're calling somebody else homosexual. So, and down there, the culture's a little bit more man-centric, so she had to explain for me that I didn't mean that. I had no idea. So there are a few things that happen that, like, I don't know if you guys know what the word Zorita means.
Yeah.
Anyway, you won't go there. I call her mom, basically. I call her
Oh.
before, but call you. Just go back. It was time to go. All right. Sorry, you didn't need to know any of that, sir.
But we did. We absolutely did.
All right, guys. So, what really gets me concerned is when I get a problem like the second one, and people have no idea how to do it. A percentage is part out of whole, fundamentally, right? So this is not 20 divided by 3 on number 2. Right? This can't be. 20 out of 3 people. What the hell did you do? That's some nifty shit. So it should be what out of what? 3 left-handed out of 20 total. And then how do I make that into a percentage? Gonna make the bottom 100? Yep. 15 out of 100, so 15%. I like it.
I did it different because I had the same amount.
How'd you do it? Oh, you probably did the is over of thing, maybe?
-3 divided by 20 equals 0.15 times 100 equals 15%.
Oh, yeah. Yeah, so you basically, instead of writing a fraction, you wrote it as a decimal. Kick ass. No problem. All right, so the next few here, the first couple of these are just exactly like the ones we did a minute ago. What is 45% of 200? This one you don't really need equation really, but if you did, what is 45? Let's put it next to it. Now watch this real quick, watch, you ready? 0.45 to 200 is 45 times 2 is 90.
I just
If,
want.
I know.
Yeah.
If you steal, no, come on, you gotta, come on. If I make him 100 times bigger and make him 100 times smaller, won't the product come out the same? I guess so. But come on, even if you never do this, just appreciate that you have this ability with their number system. 45 times 2. Bam. See, I mean, so many of those are so easy now. Not all the time. Don't get, if you had 37.6% of 1,947, I ain't gonna help you there. But nice round numbers, oh shit, yeah. Or another way to look at this, what's 45% of 100? It's almost by definition. What's 45% of 100? 45. So what's 45% of 200? Twice 45, 9.
45 plus 45
Yeah?
is 90.
No?
I
Yes?
went way too complicated with that.
Yes? All right. Oh. 72 is what percent of 130? What's this look like? 72 equals. Good. What percent of, so you're going to multiply x times this, and we write it like this more generally. But you could put x times 135. But no matter how you write it, what are you going to do next? Divide. I don't think I said round, but that might have been evil. I don't know what that comes out.
You did say round.
Oh, I did? Ah, good job. Pass, Jeff. Oh, I did. So, I mean, I don't know. How does that come out?
53.33%.
Okay, 53. Oh, I see. So it came out to be 0.5333 forever?
Yeah.
Neat. Which would be 53 become a thing. 0.33% if you round it there. Okay.
Yeah, Jeff, you
Yeah,
definitely said thousands.
as a percent, sure. All right.
I'm marking a point off on that for you.
Yeah. So you can have it as a decimal. I want it as a percent though. Yeah, tens, hundred thousands. I like it. All right. Okay. Did I put 1, 2? I swear to God. Not good with numbers and letters. C says 2 is, what does it say?
2 is 5% of 1.
All right. These kind of problems now are easy, right? I mean, you should start to see them as they are equations. They just haven't been written that way yet. So 2 is 0.05 x. Watch this. 200 divided by 5. Do the same kind of trick. Sorry. Oh, David. Who's that? I never saw the YouTube parody of David Bloom. Look at it. David Bloom. Leave us alone. All right. And then let's see. The next two kind of get progressively more into real word problems. I don't really call those real word problems. Ew, Jeff and his requirements for being a word problem. But the tax on a new car was $1,600. This sounds so very much like a problem we did earlier, right? It was $1,600, which was 8% of the cost of the car. So that is almost one like those, just with a few extra words. Right? Sounds like that, just a few extra steps. So 1,600, which was
8%.
8% of this thing I don't know. Yeah. And then you just have to
25.
divide by 0.08. You know, Jeff would do this kind of weird shit. Yeah, so you get 20,000. No, that's so funny.
That's somebody.
Beat it, you dumb.
I couldn't see you.
Chewing the laser get really. All right. A laptop cost. Now this is the hardest one on here, and we got like 2 minutes. A laptop cost $2,002 after a 10% markup. So this is such an evil problem because you can't just. So the most common thing I see people do is they take 10% of 2002 and subtract it. Or yeah. Why is that not right? So let me ask you this. Here's the situation. Let's say I was working somewhere back a few years ago and I was making $10 an hour, right? And they decreased my pay by 10%. Can anybody tell me how much I'm making now? Good. So 10% of 10 is 1. So now I'm making $9. I go and I'm like, what the shit? And they're like, oh, we're so sorry. We made a little error. Well, increase your pay by 10%. And I'm still pissed. Why am I still pissed? No. They increased it by 10% and said, we're going to pay you that.
Increase it by 10%.
There you go. So 10% does not equal 10%. What is it of? So when they decreased me, I was at 10. 10% of 10 is 1. Now I'm at $9. If they increase my pay by 10%, 10% of 9 is 90 cents. Now I'm making $9.90. And your first job, especially my first job, I was making $3.20 an hour. Thank you very much. When you get like a quarter, like a 10-cent raise, that don't sound like much, but it's a lot. It adds up over time. Anyway, you guys kind of see what I'm saying? So you can't just take 10% of 2002 because that's not how I got to 2002. I took 10% of a smaller number to get to 2002, didn't I? So one way you can do this is, what do I not know?
The original price.
Original price. So here's something you can always do. This is not going to be part of your solving it. It's part of your understanding it. Give me a number for that. Just make something up. Something a nice round number. Huh?
270.
A nice round number.
70.
I love you guys. $10,000 laptop.
4.
4.
2,500.
Say 1,000. I love you guys.
That's it.
Can't you guys make a round number?
That's right.
4 is round.
2,500.
$1,000. Now, how would I figure out the new price if they were going to mark it up by 10%?
Multiply that by
And then add it.
So wait, I know you guys know. How would you guys, if you're going to mark this up by 10%, how would you figure out the total price it was going to cost somebody coming into my store? Do what? Say again?
1,000 plus 10% of. 1,000.
Yes. So multiply it by 10%, multiply by 0.10, and then add that on top of 1,000. So it's 1,000 plus a markup of 10% of 1,000. And that would equal the new price, right? All right, now what in here did I just make up?
1,000.
And what is it? What do I actually have to call it? Because I don't know what the shit is.
P.
Or P. I like it.
For
So
price.
let's replace that with X. The original plus 10% of the original is how I got to 2002.
I did. Is it still this? Because I think it's the same thing to do 1.1x equals.
Yes, that would be the next step.
Yeah. Okay.
Because it's a whole x plus 0.1x, 1.1x. I love it. So that's sort of like a shortcut I'll talk about after we do a few more of these. So watch this. This is so cool. If it was a discount of 5%, it would be x minus 5% of x is whatever the sale price is. Discount. Markup. Maybe?
Mhm.
But it's not as simple because what goes into making a sale price, two things go into it. The amount it changed by and the amount it was. So that's why it's not like a one-step problem, because you're doing everything kind of thinking about it backwards. But you guys see what I did with giving x a value, seeing what I would do with it, and then you do the same thing with x. That's such a cool trick. You can kind of, because your brain will latch on to numbers, it ain't going to latch on to freaking x as easy. Right? So like you said, the next step here would be, what's x plus 0.1x?
1.1x.
1.1x, yeah. And then I just divide by 1.1. I think I made it come out nice. Yes?
So initially, I did it differently, where I sit there and I put it 2002 equals the same thing, and then I subtracted. After I multiplied everything, I subtracted and I still got the same number.
Subtracted what? We haven't even gotten a number yet.
Well, I erased everything because I did it wrong. But I ended up getting that, well, same number I just had.
So what's this come out to be?
1820.
1820. Watch this. What's 10% of 1820? 182. What's 182 plus 1820? 1,002. Exactly. Blink. No, sorry. That's bad. That's enough. I won't subject you to any more math or stupid puns. So that's section 3.2, by the way. That's all about percent.